Africa is literally tearing apart. And in 2025, scientists watched it happen in real time. The ground in Ethiopia ripping open. Fissures wide enough to swallow roads. And shake entire villages. This story is unfolding right now, beneath people's feet. In one of the hottest, harshest landscapes on Earth. What's driving it? A hidden force deep below the crust. A pulse of heat rising from the mantle like a heartbeat. Its surges are captured in seismic data recorded this very year. If you've ever wondered what it looks like when a continent begins to split, this is it. Welcome to East Africa. I'm Mark Watts, and this is Deep Science. Afar, Earth's furnace. This is the Afar region, a landscape so extreme it feels almost alien. Temperatures soar past 115 degrees Fahrenheit 45 degrees Celsius. The air shimmers, salt flats stretch to the horizon, and volcanoes, some active, some long dormant, dominate the skyline. And at the center of it all is Erta Ale, a lava lake that has churned and glowed for decades, one of only a handful like it on the planet. Its surface never rests. Crusts form and tear apart in a constant cycle of creation and destruction. Yet this harsh land shaped us. Fossils of Auroran tugenensis, Ardipithecus, and the famous skeleton Lucy were discovered here. Afar is both the cradle of humanity and the stage for Earth's next great geological act. This region is a triple junction, where the African, Somali, and Arabian plates meet. Three giant puzzle pieces pulling apart at once. Rising heat below weakens the crust, and ancient fractures guide the split. Press on an old crack in a wooden table, and it breaks exactly along that weak line. Afar is doing the same thing, but with an entire continent. Here we can watch a continent rupture in real time. How continents split. Plate tectonics drives this transformation. Massive slabs of crust drifting, only centimeters per year, about the speed your fingernails grow. But over millions of years, that tiny motion reshapes continents. In East Africa, tension pulls the land in several directions at once, like dough stretched too thin. The crust begins to crack, thin, and finally tear. The East African rift has two great branches. The eastern arm running through Ethiopia and Kenya, and the western arm tracing a line of Great Lakes, like Tanganyika and Malawi. Some segments rupture in violent earthquakes, others ooze lava quietly. Together, they form a scar across Africa that lengthens every year. When the stretching becomes too fast or uneven, the stress releases suddenly. The ground jolts, collapses, and sometimes splits open overnight. That's exactly what happened in 2005. The 2005 event. When the Earth opened. In Afar, a swarm of earthquakes rattled the region. A deep rumble followed. Then the ground tore open. In less than 2 weeks. A 37-mile, 60 kilometers. Cracks slashed across the desert floor. Roads buckled. The landscape changed in an instant. What people saw was only the surface expression of something bigger. A massive magma dike, a blade of molten rock, forcing its way upward like a fiery crowbar. It widened the rift by as much as 8 meters, practically overnight. For scientists it was extraordinary. Africa's breakup had long been theorized, but here it was happening live. For the people living there, it was a terrifying reminder. This land is not stable ground. It is the front line of Earth's tectonic power. But the 2005 rupture was also a clue. Evidence of something deeper driving the system. The plume. Africa's hidden heartbeat. To understand the rift you have to go underground. Deep in the mantle, rock is solid but can flow under pressure. Rising through it is an enormous mantle plume. Column of superheated material. Acting like a slow-motion blowtorch, pressed against the base of Africa. For tens of millions of years. It has softened the crust, and primed it for splitting. But this plume doesn't rise steadily. Pulses, like a kinked garden hose releasing bursts of pressure. Each surge cracks the crust, lifts the land, and sometimes tears it open. In dramatic events like the 2005 fissure. How do we know this isn't just theory? Earth leaves evidence. Seismic tomography reveals slow waves beneath afar, the signature of hotter, softer rock. Lava chemistry points to astonishing depths, possibly near the core mantle boundary. GPS satellites measure the land pulling apart, millimeter by millimeter each year. Together they tell one story. Afar sits atop a deep, living engine, reshaping a continent. Surface clues. A land in motion. On the surface the signs are everywhere. Volcanoes rise from the desert floor. Some smoke, some sleep. And others are sheathed in fresh black lava flows. Only decades old. Geologists collect ash, pumice, and lava shards. Minerals that act like time capsules, recording the pressure and temperature. Where the magma formed. Networks of seismometers record. Hundreds of tiny quakes each year. Whispers of the crust cracking below. GPS stations show the rift widening. The valleys slowly sinking. The ground sagging like a stretched fabric. Pulling apart. Afar is a living fracture. When the ocean arrives. If the rift keeps stretching, the land will eventually sink below sea level. When that happens, the Red Sea, or the Gulf of Aden, will pour into the valley, flooding it and forming a brand new ocean. Imagine standing on desert sands today and seeing waves roll in tomorrow's coastline. Africa will split in two. To the west, the main continent. To the east, a new landmass carrying Ethiopia, Somalia, and the Horn of Africa. Between them, a young ocean, slowly widening. The timeline is uncertain. Tens of thousands of years. Maybe hundreds of thousands. But in geologic terms, that's a blink. And as 2005 showed, sometimes the Earth jumps forward in sudden leaps. Earth's endless cycle. The Atlantic Ocean began exactly this way. A rift much like afar. South America pulled from Africa. The land sank. And seawater rushed in. Afar gives us a rare front row seat to that same process today. Other parts of the world are stretching too. In Iceland, the mid-Atlantic ridge splits the island in half. You can literally stand with one foot on North America and the other on Eurasia. In the western United States, the basin and range is lengthening. Its mountains and valleys created by a crust under tension. Some geologists believe the Gulf of California could one day extend northward, flooding parts of Arizona and carving a new ocean basin. The planet is always remaking itself. Why it matters? Africa's rift affects more than geology. Earthquakes threaten communities. Volcanoes can disrupt air travel and even cool the planet. Millions live along the rift. Their homes, farms, and water supplies depend on ground that is constantly moving. Yet the region also holds opportunity. Immense geothermal energy, waiting to be tapped. Afar isn't just a scientific curiosity. It's a reminder that Earth is alive and in motion. For us, creatures of decades, change feels slow. But to Earth, 1,000 years is a heartbeat. We will never see Africa fully split, or the new ocean that will flood its deserts. But we are witnessing the opening act. Cracks widening, volcanoes erupting, valleys sinking, and somewhere far beyond the rift, the planet leaves other clues. Like a massive boulder perched high on a cliff in Tonga. Too heavy to lift, too far inland to wash ashore. What force was powerful enough to hurl it there?